Hello everyone. In this session of CCNA series, I will discuss about a routing protocol called OSPF and its basic concepts. OSPF, also known as Open Shortest Path First Protocol, one of the most widely used interior gateway protocols in IP networking. OSPF is a link state routing protocol. A link state routing protocol uses SPF algorithm, also known as Dijkstra's algorithm, to populate the routing table and find the shortest path to a destination or all known destinations. So link state protocols are like your navigation system. They have a complete map of the network, and if you have full map of the network, you can calculate the shortest path to all the different destinations out there, like you use your navigation system to reach a particular destination. Link state protocol functionality is pretty much simple and similar to a navigation system. Here, each router establishes a neighbor relationship with every adjacent router. So after neighbors are formed, each router sends out link state packets between each other. So each router, after sharing the link state packet, they will store a copy of all those packets in a topological database. Okay, the database on all the routers should be identical. That is the main, key concept of OSPF or link state protocol. The link state database describes the graph of the internetwork from this topological database. And using Dijkstra's or SPF algorithm, each router calculates the shortest path to each network. And then once the shortest path is found, it enters this information into the routing table. So this is how the link state protocol operates. So OSPF uses cost as its metric. So when I say metric, a routing protocol may occasionally discover multiple paths to the same destination. So the routing protocol must be able to determine and identify the available options to select the best possible path. And this is accomplished by using routing metrics. If you see, there are two paths available from a source to a destination. So path 1 through router R1 and path 2 through router R3. So a routing protocol should be able to identify which path is the best path. This is where the metric comes into the picture. So routing protocols choose the best route to reach a subnet by choosing the route with the lowest metric. Okay, so every protocol uses its own metric, but the OSPF calculates the shortest path to a network by analyzing the cost of the route. As I said, OSPF metric is equal to cost. So OSPF, the cost value is derived from the bandwidth values in the path. Okay, so the formula used to calculate the OSPF cost is equal to reference bandwidth divided by interface bandwidth. By reference bandwidth, I mean the default reference bandwidth is 10/8. That is 1 with 8 zeros. That is 10/8 BPS divided by interface bandwidth in BPS. For example, if you see over here, I have cost 1 for 1G link. We got these values from this formula. If you have 10G link, 1G divided by interface bandwidth, 10⁸ divided by our interface bandwidth, that is 1G. If you divide this, you will get the value of cost is equal to 1. And if you have 100 Mbps link, if you divide our reference bandwidth, that is 10⁸ by 100 Mbps, then you will get a cost of 10. This is how the cost is calculated in OSPF. And if you see, if I add these two these two cost is equal to 1 for both 1G link, the cost will be 2, the total path cost. And if I take this path, the cost will be 11. So obviously the preferred path will be this one. This is how the metric helps us to find the best path. OSPF is an open standard protocol that provides, in OSPF there are two versions, OSPF version 2 and OSPF version 3. So OSPF version 2 is an open standard protocol that provides routing for IP version 4. Similarly, OSPF version 3 is the version that supports IPv6. So these are the two different versions in OSPF. And there is only one downside that is regarding the OSPF, is that it is more CPU intensive than a distance vector routing protocol. Apart from that, OSPF is the most widely used protocol in the network. That's it for this session. I hope this was informative for you. Thank you for watching.